Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic, list common multiple. And for this lesson, we're going to look at the LCM of given numbers by the method of prime factorization. So we want to see prime factorization method of finding the LCM of given numbers. So we will do So we'll review a prime factorization, and then we'll look at the finding the LCM by prime factorization method, and then at the end of the session we'll be able to give you some questions to help you with practice and also to help you gauge your understanding of the concept. So we have our first example here where we're supposed to use prime factorization method to find the LCM of 30 and 60. Remember, previously we have looked at two methods of finding the LCM of given numbers. We've looked at listing method, where you just list the factors of the multiples of given numbers, and then you look at the common multiples and then you pick the least among them. We also looked at successive division, and now we are looking at prime factorization method. So prime factorization method, we basically need to express this number 30 here as a product of its prime factors in power form. We also express 60 here as a product of its prime factors in power form. And remember, previously we looked at that, and we have said that before that we can use factor tree, or you can also use successive division method to help you come up with the prime factors of 60 and 30. So let me use factor tree. So I want to start with 30. So on this other side, we write the prime factors. On this other side, we write the result. So 2 divides 30 15 times. So you're supposed to continue with that until when the number on the right hand side of the branch is a prime number. So 15 is not prime, so we have to continue. So 3 goes there 5 times. So you can see 5 is now prime. So the prime factors are this. So it then means that 30 can be written as 2 times 3 times 5, each of which is raised to power 1 because they are all appearing only once in the product. Let me look at 60 then. So 60, we start with 2, goes into 60 30 times. Again, 2 goes into 30 15 times. 3 goes into 15 5 times. So once we have the prime number here, we stop, and then we only pick these numbers. So it means 60 can be written as 2 times 2 times 3 times 5. So that is usually the first step, where you express both numbers 30 and 60 as a product of their prime factors in power form. So we have 30 equals to 2 power 1 times 3 power 1 times 5 power 1. Then you have 60 equals to 2 power 1 times 3 power 1 times 5 power 1. So we have the least common multiple of 30 and 60 is equals to. Now, when it comes to LCM, you pick all the prime factors that you can see. You see, we have 2, we have 3, and we have 5. So we pick all of them. So we start with 2, and then you multiply by 3, and then you multiply by 5. Then again, you pick the highest power of each. For example, here, 2, the highest power is 1. 3, again, the highest power is 1. And 5, again, the highest power is 1. So 2 power 1 simplifies to 2, 3 power 1 simplifies to 3, and 5 power 1 simplifies to. So this is 6 times 5, that is 'I think we made a mistake somewhere here. 2 here. 2 is appearing twice, so 2 is supposed to be power 2. But then 3 is power 1, and then 5 is power 1. That is when you are writing 60 as a product with prime factors. You see 2 here is appearing twice, so it's supposed to be 2 power 2, 3 power 1, and then 5 power 1. So when it comes to finding the LCM, the highest power of 2 is 2. So that is what you pick. And then 3 remains to be power 1, and then 5 is power 1. So the highest power of 2 is 2, the highest power of 3 is 1, and the highest power of 5 is 1. So this one here will change. So you have 2 times 2 times 3 times 5. 2 power 2 is 2 by 2 by 3 by 5. So 2 by 2 is 4 by 3 by 5. So I will multiply 5 by 4 first to give me 20, and 20 by 3, that is going to give me 60. So the LCM of 30 and 60 is 60. Remember, from our definition of LCM is the least number for which the given numbers divides into without leaving any remainder. So that is basically how you go about it. Let's look at another example here. So here we are supposed to use prime factorization to find the prime factorization method. So method is missing here. So prime factorization method to find the LCM of 72, 96, and 300. So the procedure still remains the same. We express each of the given numbers as a product of their prime factors in power form. So let me start with 72. So 2 goes into 72 36 times. 2 goes into 36 18 times. 2 goes into 18 9 times. And 3 goes into 9 3 times. So once you have the prime number, we stop. You pick all the prime factors. So 72 can be written as 2 by 2 by 2 by 3 by 3. So we have 2 raised to the power of 3 times 3 raised to the power of 2. Then again we have 96. So 2 goes into 96 48 times. Again 2 goes into 48 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. And 2 goes into 6 3 times. So once you have the prime number, down there we stop. Then you pick all the prime factors. So that means 96 can be written as 2 raised to power 1, 2, 3, 4, 5. You're going to multiply 2 5 times, and of course 3 raised to power 1. Finally, we have 300. So 2 goes into 300, 150. 2 goes into 150, 75. 3 goes into 75, 25. And 5 goes into 25 5 times. So once we have the prime number there, we stop. Then you pick all of them here. So 300 will be written as 2 power 2 times 3 power 1, and then times 5 raised to power 1. So now we have the LCM of 72, 96, and 300. So this is going to be equal to, so we pick all the prime factors. So we have 2, and then we have 3, and then we have 5. Then now, remember, now when it comes to the LCM, you pick all the prime factors, 2, 3, and 5. So there is 2 here, there is 2 here, and there is 2 as well in the prime factorization of 300. So after that, you pick the highest power of each of the prime factors. So 2 power 3 here, 2 power 2, and there is 2 power 5. So the highest power is 2 raised to power 5. Then 3, we have 3 power 1, 3 power 2, and 3 power 1. So 3 power 2 is the highest. And of course 5, we have 5 power 1. So somewhere here, there could be 5 power 0. There is no 5. So 5 power 1 is the highest. And so this is the LCM. So we can simplify it so that we have 32. 5, 2 raised to power 5 is 32. And then this is 9. And then this is 5. So we have 32 by 5 is 160. So we have 160 by 9. So that is going to be 0. 9 by 0 is 0. 9 by 6 is 54. So 4 carry 5. 9 by 1 is 9 plus 5 is 14. So this becomes the LCM. 14, 1440. So the LCM of 7296 and 300 is 1440. If you had to use the prime factorization method, that is how you go about it. So we have example number 3 here, where we are supposed to find the LCM of 100, 150, and 200 still using prime factorization method. So let's see. So 100 as a product of its prime factors will be 2 by 2 by 5 by 5, which is 2 power 2, and 5 by 2. 150 will be 2 by 3 by 5 by 5, which is 2 power 1, 3 power 1, and 5 by 2. And then now we have 200 is 2 by 2 by 2 by 5 by 5. So this one here will be 2 power 3 and then 5 power 2. So the LCM of 100, 150, and 200 is going to be, so you pick the prime factors here. We have 2, 2, and then we have 3, and then we have 5. So for LCM, you pick all the prime factors, all the numbers that you can see. So we have 2, there is 3 here, there is 5. And then you pick the highest power of each. So we have 5 power 2, 2 power 2, 2 power 1, and 2 power 3. So 2 power 3 is the highest. Then 3 again, we have 3 power 1, which is the highest. And then we have 5 power 2, 5 power 2, 5 power 2. 5 power 2 is the highest. So this is 8, this is 3, and this is 25. So 25 by 8 is 200. You multiply by 3, and that is giving us 600. So 600 is the LCM of 100, 150, and 200. So B here, we have to express again each of the numbers as a product of their prime factors in power form. So starting with 200, So again, 2, 100, 2, 50, 2, 25, and 55. Then we have again 300, 2, 150, 275. 3 divides 75 25 times, and 5 divides 25 5 times. Then we have 500. So 2, 250, 2, 125. Now 5, 25, and 5 5. So for 200, I will only pick this. So I have 200 is equals to 2 power 3 and 5 power 2. Then we have 300, 2 power 2, 3 power 1. You can see them here, 2 power 2, 3 power 1, and then 5 power 2. And we have now 500. So 2, 2, so 2 power 2. And then there is no 3, so we have again 5 power 3. So in finding the LCM of 200, 300, and 500, we pick all the prime factors. We start with 2, then there is 3 there, and then there is 5. So you pick the highest power of each. So 2 highest power is 3, 2 power 2, 2 power 2, 2 power 3 is the highest. Then 3 again, the highest power is 1, and 5 again, the highest power is 3. So this again, if you simplify it, you'll have 8 by 3 by 125. 5 raised to power 3 is 125. So if you simplify this, so we'll have 125 multiplied by 24. So we have 4 by 5 is 20, 0 carry 2. 4 by 2 is 8 plus 2 is 10, so 0 carry 1, and 4 by 1 is 4 plus 1 is 5. We add 0 here, then 2 by 5 is 10, so 0 carry 1. 2 by 2 is 4 plus 1 is 5, and 2 by 1 is 2. Then you add all these 0, 0, 0, 3. So this is giving us 3000 as the LCM of 500, 300, and 200. So that is how you go about it. That's how you find the LCM using prime factorization. So we have some few questions here to help you practice, and also to help you get your understanding of the concept. Otherwise, that marks the end of the lesson. Goodbye.